let us start. I hope the slide is visible.
Yes, sir.
Okay, okay. So we have broadly covered two big areas of C++ programming as a strong example of what a object-oriented programming language can do and how you should go about using that language. Very powerful language, lot of features, but needs a good understanding and a proper use of the language. One part that we have covered at the beginning had to deal with what we called better C. That is, these are procedural extensions on C for C++, which has had two objectives. One is to make the procedural programming more safe, more correct, better quality, and easier to write. The other part, and overlapped with the first part, is to provide facilities so that object-oriented programming can be facilitated better. Then the second part dealt with the first basic principle of object-oriented programming, which is data encapsulation or information hiding. In that, we introduced classes, their selective access properties, private and public specifiers, and various lifetime related aspects of class instances as objects, starting from variety of constructors, destructor, copy constructor, copy assignment operator, and so on. And specifically, we took a look into overloading different operators for your specified class, which help us make it easier and again safer to write programs, which make it possible that we can have a complete user-defined type created, which behave in a way similar to the predefined built-in types. And we saw variety of aspects in this information hiding principle, which empower us to very selectively create classes, write classes, having objects, hiding its internal state and exposing its behavior, its services. Today, and in the next couple of classes, we will get into the more important or a very significant principle of object-oriented programming or object-oriented analysis and design, which is called inheritance or specialization, generalization, hierarchy, which has not only a lot of impact in terms of programming, but it has a significant impact in terms of how you design your system, how you design your classes, your objects, and becomes a kind of a building block for a very efficient and easy code reuse. Code reuse is a very significant principle of software engineering. That is, you should always be able to reuse the code that already exists, that has already been tested, instead of having to write it again with maybe small changes. So to minimize this proliferation of code, there are common design principles which can be discovered, design avenues which can be discovered, which help us in designing and implementing a better, more organized, easily understandable, readable system, which are all desired properties of the software engineering paradigm. So we will introduce the concept of inheritance in object oriented terms, and then we will elucidate with how do you achieve these kind of designs in C++ programming language. So that is our next premise to start with. So the basis of inheritance or specialization generalization principle is a fact that in real world several of the situations or several of the objects that we need to model are interrelated between themselves. They share a lot of properties and have some special ones. Object-oriented analysis and design models this using a spatial relationship called a is-a relationship. And C++ will model is-a relationship by inheritance of classes. Let us see what is-a relationship means. It is a very simple idea. Think about a rose. We all are familiar with rose. And I will say rose is a flower. Why I say rose is a flower? Because rose has the properties of a flower. Like it has fragrance, it has petals, etc. But rose also has some additional properties. Like it has a fragrance which is different from the fragrance of jasmine. So rose is a flower because it has fragrance, but it has some special fragrance which makes it, say, the rosy fragrance, which makes it a specialization of flower. On the other hand, we will say flower is a generalization of rose. It is some one kind of flower is one of the kinds of flower is rather encapsulates all kinds of flowers, be it rose, be it jasmine, be it anything else. Similarly, I can say that red rose is a rose because red rose has all the properties of rose, like rosy fragrance. But it has an additional property that its color is red. So red rose is a specialization of rose. Rose is a generalization of red rose. This is the basic idea of is-a relationship. So we depict is-a relationship in terms of this diagram. We will see more of it when we discuss UML, Unified Modeling Language for Object-Oriented Analysis and Design. But right now we just learned this very fundamental diagram where the classes or the concepts, also called entity sets, are written by their name within rectangular boxes, and you draw an arrow from a specialized entity to a generalized entity, and that arrowhead is a open head. That is, you have an arrow with a kind of a arrowhead which is a triangle which is not filled up. And this fine part is important because we will see that they will add a lot of semantics when you go to UML. There'll be a difference in terms of if the arrowhead is just, two angular lines, or if it is a filled up triangle and so on. For inheritance, for is-a relationship, it is a open triangle at the end. So whatever I wrote on top is summarized in terms of a diagram saying that red rose is a rose. This is how I will read. Rose is a flower. Now think about another situation. We have, we all know two-wheelers. We all know three-wheelers, autos, totos these days and so on. And in general, we know vehicle. So we will say that two-wheeler is a vehicle. Three-wheeler is a vehicle. So it is possible that in case of rose also, in case of flower also, I could have drawn that kind of a diagram. I could have said jasmine is a flower. Here I'm saying that two-wheeler is a vehicle, three-wheeler is a vehicle. So I can always, I have a is a relationship between two-wheeler and vehicle as well as between three-wheeler and vehicle. This is the basic idea that we are trying to elucidate. A third example is in an organization, there are several employees, but some of the employees are manager. So I'll say manager is an employee. Manager is an employee. What does that mean? That manager has all the properties of employee, but managers will have some additional properties. For example, they have a list of people whom they manage. They will probably have an additional uh, part in their pay package and so on. Right? So this is the basic conceptual idea of is a relationship. Now we categorize is a relationship in certain because by their structural properties. For example, manager is an employee. This relationship is called a single inheritance. You have a single entity which is specialized by another single entity. And we will write that in C++ in this way. So the concept of employee is class employee, which we call the base class. And concept of manager is class manager, which we call the derived class. And the easy relationship is written in this syntax that after the name class manager, we put a colon as a separator, write a keyword public. This keyword public here is same as the keyword in access specifier, but the semantics is completely different. And that comes out because of the context in which it is used. Here it means class manager colon public employee means manager is an employee. This is what we are saying in terms of C++. If we say two-wheeler is a vehicle, three-wheeler is a vehicle, we call that a hybrid inheritance. That is, multiple entities are specializations of the same entity. Usually we'll have a mixture of all of that. We'll see. So how do we put that in C++? Class vehicle, we call the root entity or the root class because it's at the, kind of looked, this is drawn in a horizontal way here. You can draw it as a vertical way also. If you draw that, it looks like the common tree notion that we have. So this is the root of the tree, which is not shown to be specialization of anything. We could, for example, we could say vehicle is a transportation device or transportation mechanism. For example, we have sheep, which is also a transportation mechanism. So we could have said that, but here we just say that two-wheeler is a vehicle, three-wheeler is a vehicle. So I have class vehicle, which is a base class. Sorry, there is a typo here. This should be vehicle, which is the root. And we have two-wheeler is a vehicle. So class two-wheeler colon public vehicle. Similarly, class three-wheeler colon public vehicle. So I have two derived classes here, two-wheeler and three-wheeler. I can write red rose is a flower. This is called multi-level inheritance. As you can see that it's going to multiple levels. So the root is class flower, which is the base class. Class rose is public flower, which represents this part. Rose is a flower, which is where the derived class is rose. Base class, there is again a typo here. This should be flower. Base class is flower. And then we have class red rose, which is public rose. So this is the one second. So red rose is a rose and rose is a flower. So you can see that for class red rows, I say public rows because it is specializing from rows. This is multi-level inheritance. So we can design the entities that are involved in my model in the object-oriented way by identifying the easy relationships between them and then putting them in C++ in terms of this, what we call public inheritance. Right? Another example from another domain to see the inheritance, our very well-known domain of phones, which is a, which is called a telephone, that is a remote calling device. So if you look at, we have landline phone, where the basic functionalities you can call by dialing, even earlier versions, or later on we had keyboard landline phones, and we have you have a behavior of being able to answer calls. Then we have mobile phones, where you can call by keyboard, Nokia 1100 kind of. It shows the number. It can dial by number, or now you can dial by name, which you could not do in landline phone. You can answer, but you can also additionally redial the last dial number or some of the earlier dial numbers. You can set a ringtone, you can add contact, you can have an address book and so on. So you can see whatever the land phone can do, mobile phone can also do, but it can do something more. Now you have smartphone, where you can call by touch screen, which shows calling by number or by name. You can again answer, you can redial, you can set ringtone, you can add contact. But now, as a part of the contact, you can also have the photo of the person whom you are adding to the contact. So you can see that there exists substantial overlap between the functionalities of these phones, and a mobile phone is more capable than a landline one and can almost perform all its functions. Similarly, smartphone is more capable than mobile phone and can perform almost all its functions, but can do something more in terms of that. So we'll say landline phone is a mobile phone, is a smartphone. We have a multi-level generalization, specialization hierarchy again. So looking in a generic form, we will say that a derived entity is a base entity. Derived is a base, and we write it as class base and class derived colon public base, as we have seen. The use keyword public after the class name to denote inheritance. Name of the base class, follow that keyword. Right? This is a quote from a very well-known commentator on C++, who is very, very active for last 2 decades in explaining the use of C++ as an object-oriented programming language. His name is Scott Myers. He has multiple books. If you see in the list of reading material I provided in the first class, I had mentioned his books. So this is from one of his books. We say public inheritance means easy. Everything that applies to base classes must also apply to the derived class, because every derived class object is a base class object also. Right? We'll see this concept even more. So now we try to, in terms of C++, talk about the easy relationship more specifically, what we expect, and we have to learn how that happens. So derived is a base, and this slide you can kind of consider having a print copy of that and keep by the side of you till you master this whole thing, because this slide will keep on coming. So if I have a situation of a derived class is a base, then in terms of data members, the derived class will inherit all data members of the base class. It will get all the data members, but it can add new data members of its own. You can just add data members. You cannot disinherit something. So its inheritance is like you inherit properties from your parents, kind of. So you inherit all data members, but you may add data members. In terms of member functions also, the derived class inherits all member functions of the base class. But after inheritance, the derived class may override a member function of the base class by redefining it with the same signature. This is something very, very critical, crucial, and we will have a lot of discussions on this. This is not overload, this is override. This is a different. In overload, which you can also do, overload a member function from base, is you can add a member function with a different signature and the same name. That is what is overloading. But overriding is something different, where you are redefining the body of the function. That is, you have the same function name, you have the same signature as the base class member function, but you are re-implementing it, saying that in the derived class, this functionality has a different behavior. So in terms of member functions, you can inherit all member functions, you can override member functions, or you can overload member functions, and you can have mix and match of those. In terms of access specification, the derived class cannot access the private members of the base class. It is only available to the base class as it were. But there is a special access specification which we will introduce called the protected access specification, where the derived class will be able to access those members, data or member function, which are protected in the base class. We will certainly talk a lot more about that. In terms of object lifetime construction destruction, a constructor of the derived class must first call the constructor of the base class, because the base class object is a part of the derived class object. So that must get constructed. The constructor of the derived class will first call the constructor of the base class to construct the base class instance of the derived class. We will see more of that. Similarly, destructor will have to do the reverse. It will have to call the destructor of the base class to destruct the base class instance of the derived class. So these are, I made a one slide gist of what inheritance or easier relationship will look like, will need in C++. And going forward, I will take different examples and take each one of these and explain the concept as well as the possible use. So this is what we have introduced, the easier relationship. Let me stop for a while and see if there are any questions. Is there any question on the introduction of the notion of easier relationship? This is a very, very fundamental, and I would say the key difference between procedural and object-oriented programming. And this concept is common to all languages which say that it is an object-oriented language. So you will get exactly the same concept in Java. You will get the same concept in Object Pascal and so on. Right? So only thing that will differ is the specific features of the language as to how you express these requirements of easier relationship in a language. Some will give you a little bit more flexibility and power, some will give you less, but overall, the concept of specialization and generalization hierarchy remains to be the key of object-oriented programming and plays a very significant role in a good engineered software project. It seems there is no question till now. It is obviously easy introductory concept. So let me get back to the slides. Now we will, as I said, that we will take up, we are again back to that summary slide. So we'll take up the first two parts, data members and member functions. What does inheritance mean in terms of those? So just, sorry, first the data members. So derived class inherits all data members of the base. and it may add new data members. So if I look at the layout of the derived class object, then that layout will contain an instance of the base class object. But derived class layout will also have data members of its own. Now, the basic question of how this layout will be done, whether the base class data members will come first from the beginning address and then the derived class data members, or whether the derived class data members will be first, then the base class data members, or they will be interspersed in certain way or not, is not specified by C++. It is a prerogative of the compiler writer, but that will not really concern if you do the programming in the right way. So let us see an example. I have a base class which has two data members. One is private, another is public. Data 1b is private, data 2b is public. I have a class D derived from the base class B, which will inherit both these members and adds a new member, say info-D. So, and then I create two instances. One is an instance of class B, one is an instance of class D, the derived class. Now, naturally, a class object B of class B will look like this. So I have data 1b, I have data 2b, the two integers one after the other. In the instance of object D, the derived class object, I will have a base class instance inside. In my presentation, I have always assumed that the base class instance is laid out at the beginning. That is just a convention I'm following, but this may or may not be true in a particular compiler. So I will have a base class instance. So I will have a data 1b, data 2b, both of them. And then I will have the derived class member info-D. Mind you, in this inheritance, data 1b is a private member of the base class. So the derived class member functions will not be able to use data 1b member directly at all, but it remains a part of its layout. So this is an interesting fact, but this kind of a embedding of the base class object in the derived class object is what will happen. And if D is again inherited by another class, then the instance of that class will embed this whole of this D with the embedded instance of B and then add its own members. It goes on like that. So this is the basic data member and object layout. Now coming to member functions, we know that we have talked about three kinds of functions in relation to a class. We have talked about member functions. We have talked about static member functions, which do not have a this pointer, which is specific to the class only, not to an object instance. And we have talked about friend functions, which are global functions or member functions of other classes, which which is given internal access to a class. So let us see first with member functions, I mean non-static member functions. So derived class inherits all member functions. It may override or it may overload, and it can add new member functions. Example is the best way to learn. So on left, you see a simple inheritance. You have a base class with two functions, f and g. Both of them, for simplicity, I've kept everything in public. And I have a derived class instance, D, derived class from B. Now, this D will inherit both f and g. So it will be available in f and g. And from this point onward, if I talk about a member function, we will usually make that use their fully qualified name. Right? So in the application, I have an instance of class B. I have an instance of class D. Now, if I call b.f1, naturally, which will get called? The function f with parameter 1 on this object. That is with the address of b being this pointer. Similarly, I can call b dot g with a parameter 2, calls b colon colon f, calls b colon colon g. In class D, I have not defined any member function, but I can still call d dot f with say 3. What it does, it has inherited the member function of b, so it actually calls the member function f in b. Similarly, I can do d dot g, exactly same as b. Okay, so this is the basic inheritance. Now look at on the right side. I have inherited f from the class B to class D. Then what I have done, I have again given a signature of f which is identical to its signature in B. I have given the same signature, void f int. This is what is called overriding. That is, I'm saying that, well, I have inherited from B, but I'm not happy with the behavior of f as given for my base class B. I want to have a different behavior. I will re-implement that function in D. So to tell that to the compiler, I add the same signature as a member function in the class, and we say this D colon colon F now overrides B colon colon F. Second, I provide another member function by the same name F, but with a different signature. Now the parameter still takes one parameter, but the parameter is not int, it is a string. It is a reference to a string, where a string is an object. This is what we called overloading, in the same way that we had thought of overloading. So we will now say that D colon colon F, taking the string reference, overloads B colon colon F, which takes int. And then I add another function H, which was not there in B. This is a new function that I add to the class D. So these are the four things I can do. I can inherit, I can override, I can overload, or I can add new. Now let's see the behavior. I have again two objects. Like the previous, if I called b dot f, b colon colon f int is called. If I call b dot g, b colon colon g is called, same as the left hand side. But think about if I do d dot f3. Earlier it was calling b colon colon f because it had inherited that. But now I have, after inheriting, I have overridden this b colon colon f taking int function in D. So now if I call d dot f, I actually call d colon colon f int. That is the function that I have given signature here for, which will certainly have a different behavior. But if I call d dot g, as I had done last time, g has not been overwritten in this class D. So it will still call the member function g of class B. So d dot g4 will call b colon colon g. So this does not change, but the earlier one changes because I have overridden. Now suppose again I call d dot f with read in quotes, which basically become a string constant. This, now you have overloading in of f in class D. There are two f functions in class D. So by this is now resolved by the overloading principle, and it matches f string reference signature. So d dot f called with read within double quotes will call d colon colon f string, this function, the overloaded function that I have given. And certainly if I call d dot h with 5, then d colon colon h will be called because b did not have any h. There's no question of overloading or overriding coming in here. Right. So again, this is a very, very important slide, Again, you can keep it as a quick reference, because in one slide you can see all different kinds of member function inheritance behavior that you can have when you specialize a class B into a class D. And very specifically, F int in D overrides B int, and F string in D, again there is a typo, there should be an ampersand, D string in F overrides B F int. So this is what we have learned. We have learned the inheritance effect in terms of the data members. All data members are inherited, and the whole entire instance of a base class object becomes a part of the derived class object, and access restrictions continue to happen in the way we had learned earlier. And in terms of member functions, it inherits all member functions and can selectively override or overload them, can do that simultaneously, as we have seen for the same function, and it can add new member functions. So this is the first part that we have learned of this. Let me check if there are questions. No. Everybody is either sleeping or understanding. Very good. Back again. Now we come to the important part of object lifetime, which is construction destruction. So before that, we will also talk about the protected access. Back to that master slide, we have talked about this part, data member and member function. So we'll talk about access specification and then go into construction destruction. This is what we are going to discuss first, the access specification. Now, we know the first two rules, which is a private specification means that only the member functions of that class can access those private members, be it data or member function. No one else can do that. That semantics continue to hold. So a derived class is outside of the base class, therefore it cannot access the private members of the base class. We also learned that any public member can be accessed by anyone outside of the class, by members functions of other classes, by global functions, and an extension of that, derived class can access, the member functions of derived class can access everything that is public for the base class. So the private and public access specification does not change their connotation. Now we have add a third layer of specification, which is called the protected access specification. I can, in the base class, I can define some members, data or member function as protected. Protected is something very interesting, which has a behavior between the private and the public. Anything that is protected is considered private for anyone who is outside of that class except for the derived classes. So no other class, that is other class means no class outside of the hierarchy rooted at this base class or a global function can access protected members. But a protected member in the base class is like public in the derived class. The derived class can access the protected members, but others cannot. Right? So it becomes, so to everyone else outside of this hierarchy, it is like a private specifier. On the hierarchy to the derived classes, it is a public specifier. This is the thin meaning of the protected access specifier, and we are due for example. So we have a base class here with private data member int data, which is inaccessible to child class as well as inaccessible to others. We have a print data method here. We have a derived class D, which adds a new data member info and tries to override the print function from the class B. It is trying to override, it's giving the same signature, because now for printing, it would like to print all the data that an object instance of the class will have. So when it tries to print the data member of class B, which is data, it is private. So the compiler says it cannot do this. It is not accessible to you. It can be accessed only by the class B members, but it can print info, obviously. Similarly, in the application, if somebody tries to do b.data, assign something as 5, this is a behavior we have known. It is inaccessible and there will be a compilation error. Now go to the right side. Instead of private, I have made it to protected. The same definition, everything else is same. There's no change. Just this private has been changed to protected. What does that mean? Now when I override the function print, this data, which is in the base class as a data member, becomes accessible to this print member function of the derived class D, because it is protected. As a private, it could not. As a protected, it can. It becomes accessible. So this will now compile. But if I still want to do b.data, earlier I could not do it because it was private. If I now try to do b.data, I again cannot do it because it is protected. And I'm trying to do it from a function which is not a member function of a class on this hierarchy starting at B. Right? So this is the thin sense of the access specifier private protected, which will be heavily used in the object hierarchy design for C++. There are exactly similar notions exist in Java as well. Now let us see what happens with a friend. So if you try to write, you have the friend function here, which takes operator output streaming. We have discussed it yesterday itself, which takes a B object. Now, if you try to, you instantiate two objects, B and D. D has an additional member, so that takes the value 2. I'm assuming that appropriate constructor, etc. exist. And then we try to do the output streaming. B will correctly print 0. D will just print 1. Why will it do that? Because this is a friend function, which is like a global, which can access, which is defined in B. So it can access only the b.data, but it has no knowledge about info because it has not been defined as a friend in D. This is commented out, right? So when you have this friend function, you will have access only to the base class instance of the object D. And though this is called with a parameter, which is a constant reference of the base class B, you will still be able to call it with D, an instance of class derived class D, because it has a base class part. Only that base class part is used in the O stream. This is what happens. To fix, you have to again include a friend function for operator output streaming in D class, which takes the D class object and prints both the data as well as the info appropriately. So now if you do, then you will have both 1 and 2 printed. So what happens when you do cout out when you stream B to C out and when you stream D to C out. Now obviously you have two friend functions. Basically two friend functions are global functions basically. So there are two streaming operators. They are overloaded now, but the resolution will happen by the fact that the first one takes a B object and the second one takes a D object. So when you invoke it with a B object, it will call this friend function and print only one component, which is data. And when you call it with D object, it will call the second friend function and will print both components. So this is how we can. So friend that way has no specific meaning in inheritance. It remains a property of the class in which the friend is defined. Okay, so we have looked at the basic access specification. Now let us look at the constructor destructor. Now the derived class inherits the constructor and destructor of the base class, but in a little different semantics. And it cannot override or overload a constructor or destructor of the base class. It will certainly have to write its own constructor and destructor, which in turn will call the constructor and destructor of the base class. Example is due. So we have a base class, data is protected. This is a constructor. We have learned all of this. This is a destructor, which actually has nothing, but I have written a message so that we can understand what is going on. Then we have a constructor for the derived class, which takes two parameters. Now what is done here is in the initializer list, you can see something which is new. What is this? We are saying the class B bracket D, which matches this constructor. So actually what I'm doing, I'm initializing the base with the value D. Now base is an object instance. So initializing it means that I have to create that object. So basically the base class constructor gets called from this point. And then it is a built-in type initialization. So here I'm constructing the base class object explicitly. I have another overloaded constructor here, which just takes the value of the derived class member info I. But you can see that it is not calling the base class constructor. Now this is also allowed provided the base class has a default constructor. Here the base class does have, because though it is looking like one, we have learned that because of this default parameter, base class constructor has actually two possible signatures, one with one parameter and the other with zero parameter called the default constructor. So here I have called explicitly with one parameter. Here I have not called. I could have also written B just parenthesis. That would also work, but I do not need to. If there is a default constructor available for base, and if I want to use that default constructor, then I may not write the constructor for the base class in the derived class initialization. And then I have the derived class destructor. So this is what will happen in the layout. If I do B5, this constructor is called and I get this object B having the value 5, one field. If I do D1, 1, 2, then the first constructor of class D is called. So I get base class object constructed through B1 gets embedded and I get the derived class data member 2 here. If I do the last one where I just pass one parameter, I'm calling the second constructor. Base class object is constructed by default with a value 0 and I have the derived class data member here. So this is how the construction will happen. Very simple, straightforward. You just have to think about the logic. Now let's say the sequence of what happens. So what will happen if I do this? So we have here given the names of functions when they are called. So in all four of these, you will see that. So this is done just for understanding, for checking out what is happening so that we can understand. So first what will happen? The base class object gets constructed with the value 0, which is object B. Then I'm trying to construct this. But if I try to construct this, I have to first construct the base class object. So in the second line, there is a constructor call for class D, which in turn calls the constructor of class B. So what you get to see is constructor of B is called with the value 1, the first parameter, in object D1. Once this is done, I is initialized to info is initialized with I. So then you call, then the derived class construction happens, and your construction of class D is D1, object D1 is over. In case of the third, you will again, when you try to construct, not explicit, but implicitly we'll call the default constructor of B. So you have B colon B int called with 0 because that is the default value for D2. And then the construction of the D2 object is completed in this constructor. You get D colon D int, single parameter constructor, and that completes the construction process. Then the use is happening. Now, when the scope ends, exactly in the same way, the destruction will happen. So what will get destructed first is the object D2 in the reverse order, as we said. So you get to object D2. Now, before it can complete the destruction, it has to also destroy the base class part of it. Let us go back. So if I want to destroy this, I have to also destroy this object containing 0, which is a base class object. So when I come to the destructor of D, before it can complete, it has to call the destructor of B. Only then the destruction is over. Next is going backwards. Next is the object D1 to be destructed. So get into that destructor, and that in turn calls the destructor of B, and this will be completed by these two calls. Finally, the first object of class B, the object B, has to be destructed. So the destructor of class B will be called. So it is, if you trace from here, you can see that if you just go backwards, this is a sequence in which it will happen, because exactly that is how it is implemented. C++ compiler uses a implicit stack where it keeps track of the order in which it has called the constructors, and it keeps on popping from the stack and calling the corresponding destructors, and that is how it achieves a very clean mechanism of object construction and destruction on a object specialization hierarchy. So this is what we have learned. Let me go back. We are also out of time. So if there are questions, let me answer that. So we have learned the fundamentals of inheritance today. What is a relationship? What is generalization, specialization, hierarchy? How to specify that in C++ using the public inheritance keyword. Well, the fact that we inherit all data members from the base and all member functions from the base. We can add new data members in the derived class. We can add new member functions in the derived class, but also we can override a member function that we have inherited. We can overload a member function that we have inherited, but functions which are friend are not inherited in that manner because it is not a part of the class design. And then we have seen the construct access specification, that there is selective access specification by protected, which in a derived class behaves like public, but outside continues to behave like a private access. And the construction destruction process, every construction of the derived class object must be preceded by the construction of the base class object. And every destruction of the derived class object must be succeeded by the construction of the base class object. Right? So this was a summary, the very, very crucial part of the object oriented design and its implementation in C++. Any questions, friends? No? Do you have any other test today? Any class tests happening?
Yes, sir.
Uh, that is the reason that attendance has suddenly fallen today. Okay. Okay then. We are also with time, so we will close today. Have a nice day and a nice weekend. We'll meet again and on next Wednesday and continue our discussions on inheritance and go on to the subsequent topics.